Welcome to OAP 2021. We're glad that you were able to attend. My name is Kevin Jamison, and today we're going to be talking about the selection and monitoring of adsorbents for complete odor control. So selection, keep in mind that odor control systems, especially adsorbent systems, the key working part of the odor control system is the adsorbent. So we have lots of clients that are very, very focused on the housing of the odor control adsorber. And while that's important, we try to remind our clients that the real heart of an odor control system or an adsorbent odor control system is the adsorbent media. So we work with our clients to focus on the selection of the adsorbent media. We take a look at what types of gases they're interested in capturing, and other factors that are very important when selecting the type of odor control adsorbent. Remember, no one odor control adsorbent captures every odor. What else is important in regard to adsorbent systems as well? Well, the monitoring of the adsorbent. The odor control adsorbent systems do have some type of a finite life, but knowing that life is not the easiest thing. And so it's very important to allow for features in the odor control system that allow for monitoring of the adsorbent consumption. So let's talk about some of the odors that are going to be common in the odor control, municipal odor control industry. So the most common that we work with in the industry is hydrogen sulfide. And in fact, I would say that probably 90% of all the specifications that we see, which are presented to us, or initial specifications that are presented to us, only focus on hydrogen sulfide removal. And while that's certainly very, very important, it does leave out a large number of odors which can cause even bigger problems than hydrogen sulfide. So without a doubt, hydrogen sulfide is the primary odor to be concerned of, but there's lots of other odors that need to be considered as well. One of the primary group of odors that we need to be concerned about is reduced sulfur compounds. So these reduced sulfur compounds are very often much harder to remove from the odorous airstream. And they also typically have very low odor thresholds and typically very offensive odor signatures as well. So hydrogen sulfide, everybody's familiar with, and it's not a great smell, but some of the odors of reduced sulfur compounds, an example would be rotten garlic smell. Well, nobody at all would like rotten garlic smell. So those reduced sulfur compounds are very important to understand. Also, we work in the industry with applications that will have amines or ammonia in there. Keep in mind that typically amines and especially ammonia have a very high odor threshold. So when we're working with those applications, they have to be treated differently because they have a high odor threshold compared to hydrogen sulfide and reduced sulfur compounds. And I can mention to you very often, ammonia and some amines can be often discounted due to this high odor threshold. So keep that in mind, that ammonia is not often a big concern in the wastewater odor control industry. Here's a chart where we show a number of common gases that are found in the wastewater odor control industry, and their description and their odor threshold, and then what type of adsorbent is necessary. Again, as I mentioned before, no one adsorbent removes every type of odor. So typically the selection of multiple adsorbent types inside of an odor control system is a pretty critical to making sure that the system provides complete odor control. So as we mentioned, hydrogen sulfide, that has that rotten egg smell. I think everybody is generally familiar with that rotten egg smell. The odor threshold for hydrogen sulfide is about 3 parts per billion. So it's very, very low, and it's the primary odor. So that's a primary focus for the odor control industry. Our recommendation for removal of hydrogen sulfide is typically to use a high capacity H2S adsorbent, like our Sulfazorb XL. These are high capacity, typically 66% by weight, so it's like a hydrogen sulfide sponge, and these are very, very long life products to capture that hydrogen sulfide to get 99.9% removal efficiency. Other gases that we work with are mercaptans. Some of the descriptions of their various mercaptans, and some of those descriptions include a skunky smell, rotten cabbage smell, putrid garlic smell, as I mentioned before. Now, those odor thresholds are even lower than hydrogen sulfide, so 20 to 300 parts per trillion. So we're in the parts per trillion range. And generally, those mercaptans need to be removed with a polishing adsorbent, like a permanganate impregnated alumina, or that's mixed with activated carbon. So just kind of a broad range, capture everything afterward type media. Our product is CPS 12 blend, which is a great product, long-lasting, high-capacity product for those gases. Some other gases include carbon disulfide. That's the smell of rotten vegetables. Nobody likes that. We're back into the part per billion range for that, 200 to 800 part per billion. Again, broad range CPS blend type product. Dimethyl disulfide, that's a really tough one. Decayed vegetables, again, in that whole category, odor threshold of 1 part per billion. Dimethyl disulfide is an especially difficult gas to remove in the odor control industry, and our permanganate media has been selected in competitive analysis to other similar products and has been by far been shown to be the best product for removal of dimethyl disulfide. Of all the gases on this chart, probably dimethyl disulfide is the one that creates the biggest headaches. Indoles and skatols, that's a fecal kind of nauseating smell from it. We're down at 1 part per trillion, so really, really low levels in that area. Again, the blended product is the best for that area. Amines, amines are typically kind of a fishy smell, not very often in the wastewater odor control market. We have worked with a number of customers who are in the seafood industry, and therefore they do have a lot of amines from actual fish processing. In that area, we're in the 400 part per trillion to 100 part per billion range, and we use a great acid impregnated carbon for that product. Our product name is Ammonia Adsorb for that. And for the removal of actual ammonia, we would use the Ammonia Adsorb product. Of course, I think most everybody is familiar with the smell of ammonia. It's a pungent, irritating smell, often used to wake up people who have passed out. So we know that smell of ammonia from cleaning products. But keep in mind that the odor threshold for ammonia is anywhere in the 17 to 50 part per million range. So that's really, really high levels compared to the other odors. And so generally, most applications don't require the removal of ammonia in order to reduce odors. Other factors to consider when you're taking a look at adsorbent media is the life of the adsorbent media. And so typically, a customer is not going to be wanting to service an adsorber system very often. And typically, a good practice is to plan enough adsorbent and to model the life of the adsorbent media to last for at least a year. That's typically a good practice. It allows the customer to budget for the removal of the adsorbent media and just provides a good, reliable system for the customer to work with. Typically, we're going to be working with customers to select multiple adsorbent medias for multiple odors. Almost never do we have a customer that has only one type of odor to remove. Even though maybe they're focused on hydrogen sulfide, there's plenty of other odors that exist in their particular odor signature. And as I've mentioned before, no one adsorbent adequately removes all odors. And so typically we're going to be working with a number of adsorbents in combination, typically in layers or in sections, to focus on their particular issue. Also, when there are very high levels of hydrogen sulfide, such as above 20, 50 parts per million of hydrogen sulfide, typically it's best to include in the system selection or the adsorbent selection a good scavenger product, which reduces those hydrogen sulfide levels to more manageable levels and protects the high capacity H2S adsorbent, which we previously mentioned. So our product that we like to recommend is the Sulfadsorb FE. Typically, this is the type product. It has an iron oxide compound built into it. It's a very low-cost product, which just does a good job of trimming down the high levels of hydrogen sulfide so that the other adsorbents can adequately do the remaining odor removal from the odorous airflow. This chart shows a number of different adsorbents and their different purposes and uses and such. So we've listed adsorbents, which are typically just plain activated carbon. So there's coal-based activated carbon and coconut shell-based activated carbon. And those are really good for, certainly capture of VOCs. They're very, very good, but typically VOCs aren't a big issue in the odor control industry. And they're generally good for capturing low levels of broad range odor removal, but they don't have a very good capacity for hydrogen sulfide. And so typically some other product is used rather than plain activated carbon for the odor control industry. So these products typically go into the category of chemisorbents. Chemisorbents are adsorbents which have been modified to give special characteristics, performance characteristics to give longer life. Typically that longer life focuses on one particular type of gas. For instance, if you're going to focus on hydrogen sulfide, a chemisorbent with a catalytic formula like our Sulfazorb XL has really high capacity for hydrogen sulfide and therefore has a very long life. It typically has a life of about 5 times longer than plain activated carbon, but generally that product is focused just on hydrogen sulfide removal. So there's a broad range of chemisorbents that you can see from the chart based on very different applications, permanganate and impregnated aluminas, even permanganate impregnated zeolites. If you didn't have a very critical application, you could use permanganate impregnated zeolites and other types of products in there that are available. So we've got some information on the chart to take a look at in regard to costs and performance and just some other general information. So I mentioned to you as before the iron scavenger, Sulfazorb Fe. So that's a whole third category of adsorbent, which is used, as I mentioned before, to trim down hydrogen sulfide levels prior to the rest of the adsorbents as far as capturing the other gases too. So once you've selected your adsorbents, then the key is being able to monitor the adsorbents once they're in use. So after startup of the system, after installing the adsorbent media, the system's active. But the next question is, and almost every one of our customers ask the question at startup, how long will this adsorbent media last? And we always answer the customer and say, well, if you can tell me exactly how much odor is going into your system and exactly what odors there are, we can tell you exactly how long it's going to last. Well, unfortunately, most customers aren't able to do that. And so generally, the way to determine how long the adsorbent media is going to last is to monitor the adsorbent media. And a traditional way of doing that is to use a sample port and take core samples from the adsorbent media in the system and return those core samples to a laboratory. PureAir's laboratory certainly runs through hundreds of samples every week from customers, and to test those samples and to give an idea of the consumption of the adsorbent media. So the adsorbent media is used in a band from the entrance to the exit of the system, and by sampling the adsorbent media, we're able to give some kind of indication of the life of the adsorbent media. So that traditional way has been around for quite a long period of time. Unfortunately, it's not always the most accurate way of analyzing it. Remember, there's only a discrete ports in the system, so it's not exactly easy to determine exactly where that consumption band is of the adsorbent media. There's sampling error, just depends on who's taking the sample as far as any type of sampling error. And it's also very cumbersome because you've got to take samples, you got to ship them to the laboratory's got to analyze it and then send the results back. So sometimes getting the results can take weeks to find out about the status of your adsorbent system. There is another way to do it, is that some adsorbent media has a color change to it. So you can use those sample ports, and if the adsorbent media you're using, for instance, the permanganate impregnated alumina products, they have a color change that goes from a purple to a brownish white. So if you take a sample from those sample ports and that adsorbent media happens to be in the system, then you can analyze to see if the permanganate has been consumed in the product, and that's a good way of getting a field sample and knowing whether your adsorbent media has been consumed. 15 years ago, PureAir developed the manual bed indicator. This was based on responses from our customer that they were unsatisfied that they couldn't get live readings in regard to their adsorbent system to find out the status of their odor control system. So 15 years ago, PureAir developed the manual bed indicator. The manual bed indicator is a special alloy rod, which is inserted through the outer wall of the odor control system and actually sits inside of the odor control adsorbent media. As the adsorbent media is consumed in a band, the media bed indicator will change colors to indicate for the customer where that band is. And so the manual bed indicator has become a standard product that's offered on all of our products currently. And the customer simply has to remove the rod about once a month and monitor the progression of the discoloration of the rod. And that gives them a good indication of the adsorbent consumption of their adsorbent media. The nice thing about this product is that if the customer maintains the data about the progression of the discoloration and actually charts that out over time, this becomes a predictive tool, and they can actually predict out when the adsorbent media will need to be changed. This tool is also often referred to as the dipstick as well. It's just kind of a nickname in the industry that has been given to it because it does is somewhat familiar to those people who are checking the oil in their car as far as a dipstick goes. So that's a standard feature, very, very helpful. But about 5 years ago, customers were coming to us and saying, we like the manual bed indicator, but don't you have some kind of electronic form of this type of a system? And so we reached out to our research team and threw that task at them to say, how do we take the manual bed indicator and make it an electronic form? And after a couple of years of research, our team developed what's referred to as the electronic bed monitor. So the electronic bed monitor is a very similar device in that it does have a rod which penetrates down through the adsorbent media, but that rod has an array of sensors that are built along the length of the adsorbent media rod, and that array of sensors feed back to a PLC. And that PLC goes through a special algorithm which we have developed, which allows the computer to take that data and predict out when the adsorbent media will need to be to change out, what the end of the life is, and it actually communicates to the customer electronically about that information. So starting with this device in the industry, customers are able to get live monitoring of their adsorbent media to know exactly what its current status is so that they know the system is working reliably, and they're able to document when the adsorbent media needs to be changed out so that they could properly plan for that. So gone are the days where customers are surprised by unexpected adsorbent media consumption and the need to put together a reaction plan in order to get the adsorbent media changed out in an unplanned way. And so this really has changed the industry in regard to the control of odor control systems and monitoring their adsorbent media life. I'll mention to you as well what the EBM has especially allowed for the industry to develop is full service media subscription plan. So this adsorbent media subscription plans, based on the development of the electronic bed monitoring system, allows PureAir to come in and retrofit existing odor control systems with our electronic bed monitor. With that retrofit of the electronic bed monitor, we are able to work with the customer to determine exactly how long the adsorbent media life will be, and to plan that adsorbent media is changed out just before it expires. And so PureAir can work with its customers to put that whole plan together. We'll monitor the system for the customer. We'll ship the adsorbent media to the customer as it's needed. We will change out, if requested, the adsorbent media and dispose of the old adsorbent media for the customer. So that full service ability to monitor and service the adsorbent systems is now available on the market. I want to thank you very much for attending our webinar today. If you have any questions, please don't hesitate to contact us at marketing@pureairfiltration.com. I'm Kevin Jamison with PureAir. Have a great day.